12 students. Just wanted to remind you and bring you up to speed because it's been a while since we've had a class about what we did in our last official lesson and then potentially what we're going to do today and this week moving forward. So it's important to remember that we started chapter 8 and we were talking about the fatigue and recovery mechanisms. And you see that I crossed out recovery because the lesson last week was all about the start of fatigue. We looked at the key knowledge and skills and then we transferred over to question 1. Breakout rooms. What do we already know? 5 things prior to learning the energy systems and now about the energy systems. And you guys were coming back talking about phosphate creatine, talking about glucose and glycogen and carbs and fats and depleting those fuels, and also talking about lactic acid. So we had a look at this diagram here, and again we broke apart the fact that we're looking at the fatiguing and limiting factors and not the recovery, because if we understand these, then we know how we can actually recover them. And then we broke into this first paragraph here, the real introduction. And we were talking about the fact that when muscles fatigue and the energy systems contribute to fatigue, we're actually talking about how do we get to that fatiguing point? Is it an intermittent or continuous activity? Are we using fast or slow twitch fibers? What sort of activities are we completing? What's the intensity? What's the duration, etc.? And what's the level of fitness amongst that athlete? We also spoke a little bit about the fact that when we do fatigue, it's a fact of not being able to contribute to produce force in our muscles the same way that we were before. We had a second breakout room where we discussed the difference between Usain Bolt's 100-meter sprint record and Euler's marathon record, and what would be the different contributing factors when they're both fatigued at the end of their record breaks. We came back in and we looked at the definition of power, which is force multiplied by velocity. So not only how much a contraction is occurring if you were to take a measurement of the strength of the contraction, but you're also looking at how quick was that strong contraction, so power. We talk about as well that fatigue occurs in 2 different aspects. Central, which is your central nervous system, which was the brain and the messages and the nerves, and the second one was peripheral, so that's actually down at the muscle site itself. And both of these occur the same time, and some of them are just a little bit more predominant than others, whether it be more predominant through the brain and the messages or more predominant through the muscle and the fatiguing aspects of the muscle itself. Remembering that we use this word homeostasis, the body wanting to stay in its regular conditions, and we talk about as well what are some of the things that we need to do, either it be passive, which means rest, or active, which means continual movement like a cool down, in order to replenish in that body. There were 3 different levels of fatigue. Local fatigue, which is simply at that one or group of muscle sites that's being used. I have sore legs. General, which means that I've been working out for the last 3 days and I am now sore from head to toe and I'm tired and my body needs a rest. And chronic, which is an illness, which means that people are really trying to overcome a suffering of overwhelming tiredness. We broke out into group number 3. If you were to make a exercise or physical activity that made ATP-PC dominant, then what would be the fatiguing factor for that person? 100-meter sprint, high jump, explosive effort, pole vault, for example, and it was the depletion of phosphate creatine stores. Then we looked at anaerobic glycolysis, and we went with something like the 400-meter sprint at the Olympics. We know that the anaerobic glycolysis system will be dominant during that time, and it will be a buildup of lactic acid, lactate, hydrogen ions. We need to know more about that. And finally, something like a marathon, the aerobic glycolysis system, and a depletion of glucose glycogen stores would really affect that person. Also overheating. So we looked at this table, fuel depletion, accumulation of byproducts like hydrogen ions, elevated body temperature, and loss of blood plasma because we're sweating, and also those neuromuscular, decreased central nervous system messages. The final part and the main part of our lesson was about fuel depletion. And we were talking about the amount of ATP in our muscles, and when we only focus on phosphate creatine, how quickly that phosphate creatine depletes, and when it does, our ATP levels deplete, which is why we have to, at that 10 to 12 second mark, rely on the dominance of other systems at that high intensity effort. We spoke about phosphate creatine. We spoke as well about creatine supplementation and the fact that that doesn't give us more phosphate creatine, but it means that the replenishment of phosphate creatines during rest happens quicker. And then we spoke about glucose and glycogen. And so essentially, to sum up these things here, we were looking at the fact that the glucose in our blood only has about 3 grams worth, the glycogen in our muscle store 400 grams, and the glycogen that is in our liver that has gone through the gluconeogenesis because it's been recreated via lactate, which we spoke about in the energy system chapter. There's the breakdown of how much of each of those we have, and we know that the glucose is the quickest because it's already in that liquidified form. Glycogen is closest in the muscle in comparison to having to transport from the liver. So we spoke about the depletion of those fuels and having to rely on fat, and that happening at that 2.5 to 3 hour mark where the fats become more and more dominant. The final question before people broke off was explain why an athlete is unable to run their fourth 100 meter in the 400 meter race as fast as their first, and you had to use the mechanisms that we spoke about in the lesson. 400 meter heavily relied on ATP-PC as well as anaerobic glycolysis. Depletion of fuels in phosphate creatine means we still need fast energy, so we turn to the anaerobic glycolysis system. Anaerobic glycolysis system produces energy a little slower than phosphate creatine, and we also suffer from a buildup of metabolic byproducts such as lactic acid. What I'm going to do now is I'm going to create another video, and that video is going to take us through the next section of fatigue and recovery, and then we will set up a Zoom at the end of the lesson for any questions. I'll see you soon.